Hi everyone, today we'll be doing the experiment on amide synthesis. At first, we pipette out 100 microliter of aniline into the test tube using a mechanical pipette. After transferring 100 microliter of aniline into the test tube, use a wooden cork to stopper the test tube. Place the test tube in the wooden block. Pipette in 500 microliter of DI water using a mechanical pipette and add it to the aniline in the test tube. Then carefully add 3 drops of concentrated hydrochloric acid into the test tube. Be careful while doing this since the hydrochloric acid is very concentrated. I believe it is around 37%. So 3 drops. As the drops are added, you can see because the hydrochloric acid is so concentrated, the solution is fuming. Then measure out 10 milligram of activated charcoal. So around 10 milligram. So that's around 0.01 gram. So that's about 10 milligram of activated charcoal. Then transfer the activated charcoal into the same test tube. Place the test tube in a wooden block and stopper the test tube once again. Shake the test tube as much as possible so that the reactants come in contact with each other as much as possible. Next step is to pipette the reaction into a reaction vial using a Pasteur pipette. While doing this, utmost care must be taken not to transfer any of the charcoal. While transferring the reaction mixture by pipetting, we are going to avoid taking the activated charcoal which does not dissolve with the rest of the reaction mixture. Then we are going to add some extra DI water into the test tube in order to wash the charcoal. The amount of water we will be taking is around 0.5 ml. So 0.5 ml of water pipetted into the test tube in order to wash the activated charcoal, and we are going to then transfer that wash into the reaction vial. Once again, avoid taking in the activated charcoal. Then put a spin vane into the reaction vial. That's the spin vane along with the reactants in the reaction vial, and we are going to attach a condenser and put it away in the wooden block. The next step is to add 150 milligram of sodium acetate trihydrate into a fresh new test tube. Then transfer the powder to a fresh clean test tube. Make sure all the powder gets transferred. To the same test tube where we put sodium acetate trihydrate, we pipette out 0.5 ml of DI water using a mechanical pipette. We stopper it, then we shake to dissolve. Notice that we shake it sideways and not up and down. Then we come back to our reaction vial, set aside in a wooden block containing the aniline and DI water and spin vane and the condenser attached. And we carefully open the condenser. We are going to add other reagents to this solution. So we fix the pipette to read 150 microliter, and then we are going to take acetic anhydride. So that's 150 microliter of acetic anhydride. Remember to close the cap for every reagent bottle. Then using a Pasteur pipette, we are going to transfer sodium acetate trihydrate solution into the reaction vial. So the reaction vial now contains all the reagents that we have measured out, along with the spin vane. Then we attach the condenser back to the reaction vial. And place the reaction vial into the aluminium block as shown. The solution will not be heated at all, but it will only be stirred magnetically. So we subject the reaction vial to magnetic stirring for 5 minutes without the heat on. After stirring for 5 minutes, we place the reaction vial with the attached condenser on the bench and wait until it cools down to room temperature. Then we transfer the vial into the ice bath. It will sit in the ice bath for 10 minutes. After the reaction vial has been sitting in the ice bath for 10 minutes, we open or as in detach the condenser carefully. This will be subjected to vacuum filtration. Need to wash the spin vane and the reaction vial and the product. We are going to do this using DI water this time. So squirt DI water over the spin vane so as to clean the spin vane as well as to retrieve as much product as possible. And then wash the insides of the reaction vial using more DI water. Then pour the rinse onto the harsh funnel. Repeat the process until the reaction vial is devoid of the products of the reaction. Vacuum dry the product for 10 minutes. So while the product is drying, the usual, we are going to measure the mass of a labeled vial with the cap. Next is to take the melting point of the compound. So we fill the capillary tube with 4 to 5 millimeter of the compound. Once the sample dries, we are going to scoop it up from the harsh funnel and collect it in the product vial as shown. Then the mass of the vial was taken with the product in it. So as we know, the melting point tube has one open end and one closed end, and when we drop the melting point tube through the rod several times, all the product is expected to collect on the closed end.
Now we place the melting point tube containing the compound inside the instrument. And yes, as we have said this before, we run it really fast until it hits close to the literature value. And once it hits close to literature value, we are going to decrease the pace of the increment of the temperature. And then, yes, we are going to let it rise little by little, like at this, we fix it 3 degrees Celsius per minute, and then we're going to make it rise little by little until we see our compound melt. And when we do see our compound melt, we are going to record the range of temperature. And um, yeah.
So that was it, guys. We synthesized an amide, and then we also did the characterization. We did not take the IR since we were not supposed to take that. We took the mass of the product by measuring the mass of the vial with the product and without the product, and then we took the melting point of the product, which is amide.
So we end our experiment by cleaning everything. We are going to first clean all the glassware. No, actually, we are going to first get rid of all the liquid waste and the solid waste in their respective containers as marked. And then we are going to clean our glassware first using an organic solvent like ethanol or acetone. We are going to clean all the glassware, and then we are going to rinse everything with DI water. So that's done. And then after all the glassware is cleaned, we are going to put them all away in their respective bins. And then we are also going to make sure that our workspace, the bench that we worked at, and the fume hood, they're all clean. And there should not be even any mark or anything. And the hot plate is kept away into a side, and everything is clean. And then we also need to throw away any broken glass in the disposable glass waste. So yeah, that's it, guys. Thanks.
Thanks. That's it. Have a great day.